Hi, this is Mr. Warden. This is the Geometry Exit Ticket, 31.2 video key. So let's go. All right, we're going to try to find the altitude to the base for this isosceles triangle. Well, the nice thing about the altitude to the base is it's going to bisect, and since it's an isosceles triangle, we will bisect this 120-degree angle. So when we draw that through there, that 120-degree angle gets split into a 60 and a 60-degree angle. So this is 60 degrees, and this is 30 degrees. So we now have a 30, 60, 90 right triangle, which is cool because then we can, and we also know that this is going to be bisected because of our experience with past isosceles triangles. So this base 18 gets split up into 9 and 9. And from there, we can figure out the altitude. Because if this is a 30, 60, 90 right triangle, then this side is the short leg and this is the long leg. Okay, because this is the leg that's opposite the 30 degrees. This is the leg that's opposite the 60. And of course, that is the hypotenuse for this 30, 60. And that's the hypotenuse for this 30, 60, 90 triangle. So the relationship, of course, is 1 to square root of 3 to 2. So this is the 1, and this is the square root of 3, 1, which means that to get from here to the altitude, we have to divide 9 by square root of 3. So 9 divided by the square root of 3 will get us that altitude. And so we want to use the rationalize the denominator approach. So multiply that by root 3 over root 3. And that was an amazing extra bumpity 3. Okay, so this root 3 times root 3 is just 3. So we end up with 9 over 3 times the square root of 3. And we can reduce 9 over 3 into 3 over 1. And so that is just 3 root 3. So 3 root 3 is the answer for that altitude. 3 square root of 3 is the altitude. Okay. We could also, if we wanted, figure out this side. This side is, of course, going to be 6 root 3 because it's going to be twice the altitude since the hypotenuse is going to be twice what the short leg is. All right. Let's take a look at the next one. We've got this spiral. This is the Spiral of Theodorus. It's on its way. You can keep following it, going around and around and around. It's pretty crazy, awesome spiral. But how are we going to find what x is? Well, x happens to be the hypotenuse of this right triangle. We don't have this base, though, but this base happens to be a hypotenuse of this right triangle. And the base of this one happens to be the hypotenuse of this one. And the base of this one is the hypotenuse of this one, which we can actually find because this is a right isosceles triangle. So that's 45 and that's 45. So this is the square root of 2. Okay, and you could have worked it out also using the Pythagorean Theorem. 1 squared plus 1 squared would equal 1 plus 1, which would equal 2. And so the square of this side is 2, so this side has to be the square root of 2. Now, we square this and square 1 to find out the square of this side. So root 2 squared is 2. 1 squared is 1, so 2 plus 1 is 3. So 3 is the square of this side, so this side is the square root of 3. Okay, that was a terrible 3 because the mouse pad stuck. That's supposed to be a 3. I don't know what that is, but it's really supposed to be a 3. But here we got square root of 3 and square root of 1, or square root of 3 and 1. So if we square root of 3, we get 3. Square 1, we get 1. So 3 plus 1 is 4. So this one is the square root of 4, or 2. It might be useful, just write as square root of 4. And so this one here, square root of 4 squared is 4. 1 squared is 1. So we got 4 plus 1 gets us the square of x. So x is going to equal the square root of 5. And that is actually how the spiral of Theodorus works. We're going to have a side that's root 2, then root 3, root 4, root 5. We keep going. Let me just write the answer. It is x equals square root of 5. And I'm going to go ahead and open up the spiral of Theodorus. Never seen it if we didn't discuss it in class. This is the spiral of Theodorus. Let me zoom back in so you can see it. Okay, and these are some neat projects that some people have done. So there it is, the spiral of Theodorus. Okay, so check it out. It's a fun thing to work with. All right, let me go back to where we were. And that is it for this video. I hope that was helpful.